This video is about enthalpy and enthalpy change, or delta H. If you look up enthalpy, there's a couple of different definitions for it. One calls it the heat content of a substance. Having a high heat content doesn't necessarily mean it's hot. It means the potential to produce heat. Another definition is it's the total kinetic and potential energy of a substance at constant pressure. In this course, we can think of enthalpy mainly as chemical potential or stored energy. For example, gasoline has a high enthalpy. It's got a lot of stored chemical potential, whereas water does not have a very high enthalpy. Chemists are interested mainly in the enthalpy change, or delta H, during a chemical reaction. Let's consider an exothermic reaction. This is one that releases heat to the surroundings. Here's a graph of enthalpy versus the progress of the reaction. This is the beginning of the reaction where you have the reactants, and this is the end of the reaction where you have the products. For this exothermic reaction, as the reaction proceeds, you'll notice that the enthalpy goes down. So we say that delta H is negative. So what happens to this enthalpy? Well, what happens is it's converted into heat. So as it's losing enthalpy, it's producing heat, and this heat is released to the surroundings. So the surroundings would get warmer or cooler. You guessed it, they would get warmer. Okay, this time we're going to look at an endothermic reaction. Remember, an endothermic reaction absorbs heat from the surroundings. Here's a graph of an endothermic reaction. Notice that the reactants gain enthalpy as they form products. So enthalpy goes up. We say delta H is positive. Where does this enthalpy come from? Well, where it comes from is heat is absorbed from the surroundings, and the reaction changes heat into stored energy, or enthalpy. So the products have more stored energy, or enthalpy, than the reactants. So what do you think will happen to the temperature of the surroundings? They'll get cooler because the surroundings are losing heat. It's being converted to enthalpy by the reaction. Let's have a look and see how enthalpy and heat are dealt with in chemical equations. In one type of equation, the delta H is written beside the equation. It's not really part of the equation. There's no plus sign or anything between them. The delta H is just beside the equation. If delta H is negative, it means enthalpy is going down, and this is an exothermic reaction. So delta H negative means it's exothermic. Here's a reaction here. Again, the delta H is beside the equation, and this time it's positive. So if delta H is positive, it means it's an endothermic reaction. Another way of showing heat is through a thermochemical equation. Thermal means heat. In these types of equations, the heat term is right in the equation. There's no delta H shown. The heat term could either be on the left side of the arrow or the right side of the arrow. If the heat term is on the left side of the arrow, this is an endothermic reaction because it's using up heat like a reactant. Here's an example. This is the heat term, and it's on the left side of the arrow. So this is an endothermic reaction. If the heat term is on the right side of the arrow, then it's exothermic. This gives off heat like a product. So here's a reaction here with a heat term on the right side. Notice there's no delta H shown here. So if the heat term is on the right side, that's an exothermic reaction. Here's a question for you here. When methane, or CH4, is burned in oxygen, carbon dioxide and water are formed, and 802.3 kilojoules of heat are released to the surroundings per mole of methane. So looking at these choices, which of the following correctly represents this reaction? So I want you to look at these, try and figure out the answer or answers, and then you can turn the video back on and check your answers. So here's the answer here. Since heat is released, number 2 is correct because the heat term is on the right side of the arrow. Answer number 4 is also correct because here the delta H is shown, and since this is an exothermic reaction, it's releasing heat, delta H is negative.